Welcome back! In this last video of the Hex Grid movement system tutorial, we are going to ensure that we can select and deselect our character showing its range of movement. Next, we are going to be able to select the destination hex, and if it is in the range of the character movement, we are going to move our character towards this point, and we are going to prevent the player from being able to reselect our character until the character finishes moving, to create this kind of turn-based movement system. So now we are going to create in our scripts, right-click, create a new C# script. We are going to call it unit. Okay. This script will be on our character object, so we are going to add selection based, so that if we select it inside the inspector, we are going to select the topmost parent of our character. Now I will paste here the code that we are going to use. Let me explain what is going on here. First of all, we have a serialized field private int movement points, which are the movement points of our unit. So this will be used by our breadth first search algorithm to detect the range of this unit. And we are going to have a public int movement points property that is a getter, so that we can get this amount when we want to plan the range or the path for our unit. Next, we are going to have a serialized field, and this will be private float movement duration and rotation duration. Now, since we are moving through the hexes, our player will take some time to move from one hex to another, so this is exactly this duration, and the rotation duration is, at the start, I will want the character to rotate towards the direction in which we are going, and if we are changing the direction of movement during the path that we are moving, we are going to also rotate. Next, we are going to have a glow highlight, just as we did on a hex grid, and we are going to make sure that if we select our player, it will glow, so that we know that this character is selected. Next, we are going to need to have a private queue of vector 3. This will be path positions, so we are going to basically give the unit the path that it needs to traverse, and the unit will handle the path, but it will never know about the breadth first search algorithm or how this path was created. The only task for the unit will be to move through the path and to glow when we select it. And we are going to have a public event action that will pass this unit, movement finished. To use this action, right click on this quick action and say using system library at the top. Now in the awake, we are going to get the glow highlight by getting the component glow highlight. Next, we are going to have a select and deselect, which will simply make the glow highlight toggle glow false or toggle glow when we select the unit to move it. This is basically the same as we had on our hex. Now, of course, this can be public. Next, we are going to have a move through path method that is also a public void, and this method will be called by the outside class to make our unit move, and this will simply assign to the path positions a new queue of vector 3 passing this list. So we are going to turn the list of vector 3 into a queue. This will allow us to get the first position using the path position.thequeue and save it as the first target. And we are going to start a coroutine, rotation coroutine, passing it first target, rotation duration, so this is the float value, and additional parameter true. So if you right click and quick action and generate this, it will generate you an invalid method definition, so make sure that you return an I enumerator. And we are going to have vector 3 end position, float rotation duration, and bool first rotation equals false. And actually, I think that we are not using it anymore because I have refactored the code in the meantime, so let's remove this bool. Sorry about this. Okay, so we have no bool value. This is only position and rotation duration. Now, to make our character rotate towards the target direction, we are going to first say quaternion start rotation equals transform.rotation. Next, we are going to assign to end position y value the same as our position.y, and this is just because so that our character will rotate on the xz plane and not look up or down, because we are going to basically rotate our character towards the direction which we want to travel. Next, we are going to find the direction, so vector 3 direction equals the end position minus the transform.position. So this will give us the direction, and we can use quaternion.look rotation using the direction and vector 3 up to calculate the rotation on the xz plane. So basically now all we need to do is rotate our character in this direction. First, we are going to check if mathf.approximately. This will allow us to compare a float value, and this will take mathf_abs quaternion dot, and this is the dot product of start rotation and end rotation. Now this is only because we want to compare if this value is equal to 1 or not. If this value is equal to 1, then it means that our character is already rotated towards this direction. If this is false, this will mean that we need to perform the rotation. And to do this, we are going to first set float elapsed time to 0, and we are going to use while loop and check if time elapsed is less than rotation duration, so our rotation will always take the same time, the rotation duration. So unless we have reached the time of the rotation, we basically want to lerp from the start rotation to the end rotation. So this will be time elapsed plus equals time.delta time. Lerp step is a float value. It will be time elapsed divided by the rotation duration. So this will give us a value between 0 and 1. And we can use transform.rotation equals quaternion.lerp start rotation. This is the start value. The end rotation will be the end value, and lerp step will calculate as the linearly interpolated value of rotation that we are going to set to the transform.rotation. So to the rotation of the character, we are going to yield return null to run this coroutine every frame. And when we reach the destination time, the rotation duration, we are going to set the transform.rotation to be the end rotation to ensure that we are correctly facing the direction. And if we did all this, this means that we have rotated correctly towards the direction which we want to travel. And next we are going to start the next coroutine, movement coroutine, that will only take the end position, and this will animate our player that it is moving from one hex to another until it reaches the end of its path. So what does this coroutine do? Well, basically we are going to save the start position of our player to be transform.position. Again, those start position and the start rotation is only to be able to calculate the lerp value for the rotation and the position. Again, we are going to set the end position y equals the start position y, and we are going to do the same. Say set the float time elapsed to 0, while elapsed time less than movement duration. So those are all the values that we have set here at the top. It basically, again, this will take again the same amount of time to move from one hex to another. We are going to add to the time elapsed plus equals time.delta time, calculate the lerp step equals time elapsed divided by the movement duration, and set the new transform.position equals vector3.lerp start position, end position, and lerp step, and yield return null to run it every frame. Again, at the end we are going to set the transform.position equals exactly the end position, and if our path position, so our q of vector3 count, is greater than 0, we want to select the next position and again repeat the start coroutine, rotation coroutine, path position dq, so take the next position from our queue and set the rotation duration if we want to change it until we reach the last position on our path. And in this case we are going to use this else statement, movement finish (invoke) to check if something is assigned to this action event. If there is a method assigned to it, we are going to call this method passing this unit as this unit has finished moving. Okay? To use it, we need to assign it to our unit game object, and we need to add here our glow highlight because it will be used to select our unit and make it glow. Now we have this material window, so we need to go to our material glow shader. We have this material already created. Let's Ctrl D to duplicate it, and we're going to call it glow material character. So this will be the glow material to show that we have selected this character. I want to set the dynamic glow to be true, and I want to set the color, well, let's set it to be this green color to indicate that this character is selected. So this will basically make it glow like this preview here, so that we know that this character is selected. So let's select our unit and let's assign our glow material to the glow material, and I'm going to override my prefab so that all the characters will use this script and the glow highlight script as well. So we are going to right click in the scripts folder, create a C# script, and let's type movement system. Okay, And the movement system class will basically be responsible for what have our selection manager done so far. So for disabling and enabling highlight of the range of movement, as well as for handling the path calculation and passing the path to our unit. So we are going to select our movement system, and again I will paste the code and explain it. So at the top we are going to save the result of a breadth first search, so private BFS result movement range equals new BFS result. So this will be the empty result, so that we do not have to worry if we pass it somewhere. It will simply contain empty dictionary and it will work. Next we are going to have a private list of vector3 int current path equals new list of vector3 int, and this will be the path that we are going to pass to our unit, as well as this will be the hexes that we are going to highlight and reset the highlight. Next we are going to have a public void hide range. Basically this is the same what we did in our selection manager. We're going to get hex grid so that we do not store the hex grid reference in our movement system. We're going to look for each vector3 hex position in our movement range, so this is BFS result get range positions, hex grid get tile at hex position disable highlight, and we are going to set movement range to be a new BFS result. We're going to have the same thing, but for showing the highlight, we're going to pass to this public void show range unit, selected unit, and hex grid. Now this will calculate the range, so it will get the selected unit and the hex grid. Right click on this calculate range, quick actions, and generate this method. And we are going to loop for each vector3 int hex position, basically the same what we did here, in our movement range.get positions, and all we will do is call hex grid get tile at hex position, and this time we are going to enable the highlight. So basically this is the same that we did here. We have disabled the highlight, calculated the result, and then enabled the highlight and printed the neighbors. Now our calculate range, all it will do is call movement range equals graph search.bfs get range, and we need to pass here the hex grid, which we have because this takes in the hex grid, and we need to pass the position. Now this time we are using this unit, selected unit, so we need to calculate the hex position for this unit. So we have this hex grid dot get closest hex, and we pass this selected unit transform.position, and for the movement range we are going to pass the selected unit dot movement points that we have created a bit earlier. So hex grid dot get closest hex, we do not have it, so right click, quick actions, and generate this method. Let's right click on this and go to the definition of this method. Now here we are going to pass world position of our unit. Now we know that our hexes, we can make it into public method. We know that our hexes are on y equals 0, so we want to set world position dot y equals 0. Next we are going to return, and we want to return hex coordinates. This is the script that has calculated for us the coordinates for each hex. And if we right click on this and go to the definition, we can see that we have those static offsets, and we have this convert position to offset method. So what I want to do is I want to set it to be public static method. So now we can use it outside of this hex coordinates class. If we pass to it a position, it will calculate for us the position, the offset coordinates. So let's save it. Let's go back to our hex grid script, and we are going to basically call on this calculate or convert position to offset, passing in the world position. So this way we are going to convert the position of our unit to the hex position that we can find on our grid, so we can find the hex on which our character is currently standing on. So now, having this, let's save it and let's go to our movement system. So now what we have done is calculated the range of movement of our character based on the character's position. We can also show the range and hide the range of movement of this character, of this unit. Next, we are going to have a method called public void show path, and this will make use of those methods that we have created. We're going to pass here vector3 int selected should be hex position and the hex grid. I'm going to check if movement range dot get range position. So this will be the I enumerable of vector 3 ints. So those are all the positions in range of the movement of our character. Now I'm going to use link library.contains, right click on this, quick actions, and say using system.link. It should appear at the top here. So now we are going to check if our range contains the selected hex position that we have clicked on. So when we have selected our player and click on a hex, if the hex is in range, I want to show the path from the start position to this selected hex. Next, we are going to call for each vector 3 int hex position in the current path. So this is the current path of our player. So for example, we have previously selected some path and now this is not empty. So what I will want to do is call hex grid.getTile@hex hex position, and I'm going to have a method called reset highlight. Right click on this, quick action, and generate it for now. Next, we are going to calculate the new path. So this will be current path equals movement range.getPath to selected hex position. And this method, what it did was run a graph search generate path BFS to generate the path from our end position to back to the start position using this while loop, and it has reversed the path. So we start from the start position, but we skip it. So we start from the next hex that our player needs to step on in order to be on the path to reach the end position that we have clicked on, so that the player will move to this position. Okay, so basically this is what happens here. And next you're going to loop for each, again for each hex in this current path, and we are going to call hexgrid.getTile@hex position, and we are going to highlight this path. So right click, quick actions, and generate this hex. So all it will do is will highlight the path that we have selected in green instead of the default white, so that we can distinguish that this is the path that our character will travel to reach this destination. We are going to handle those two methods after we finish the movement system script. For now they are empty. So next we have two more methods. One is public void move unit. It will take unit, selected unit, and the hex grid. We're going to debug.log moving unit selected unit.name, and we are going to call selected unit move through path that we have created a while ago. We're going to pass the current path, but now we need to select not the hex positions but the default positions of the transform. So again, we are going to use link library, take in all the vector 3s, so those are the hex positions in our hex grid. We're going to access hexgrid.getTile@. So we are going to access the hex component, and we are going to access transform.position. So basically we are converting the hex positions to transform positions of each hex. So we call toList to pass this list of vector 3s, which are now the world position of each hex. Because we are moving on in the world position, but our hex grid is only for the storage of our data and for calculations like breadth first search. And last method will be public bool is hex in range, so we can ask a movement system if this hex is in range. Vector 3 in hex position, it will be the argument, and we are going to return movement range is hex position in range hex position to basically return true or false if we can move to this position or if it is outside of the range. Okay, I know this is a lot of code, but this is the last thing that we need to do to make our unit move. So we are going to go back up where we have this enable highlight and disable highlight. And I'm going to right click on one of those methods and go to the definition to move to our hex. So now what are we going to do? Well, basically our reset highlight will simply call our hex highlight reset glow highlight. Okay, and our highlight path will call highlight dot show valid or highlight valid path. Okay, again, we need to right click on those methods, quick action, generate them in our highlight, and we can right click on one of those and go to the definition. Now we are back in our glow highlight. Now what are we doing here is we will want to simply highlight the path that we want to move on in green, while the range will remain in white. To do this, I'm going to simply create at the top a new variable color valid space color equals color.green. Now, besides this, we are going to also need to save the original glow color, so the color of our default material, just because if we want to reset it, we need to reset it to the original color that we have set on our material. So to get it, in the awake we are going to type original glow color equals our glow material dot get color, and as you might recall, we had this underscore glow color property. Let's check it, let's save it, let's copy this just in case. Let's go back to Unity. Okay, let's select our shader, let's open it up, and we should see in our glow color we had this reference actually without the underscore, so let's paste the same name as we have used in our script, or the other way around. Let's save this asset. So now we can access this color through the script using this reference name. Great, so now we have saved our origin color, and we can use the same property to set this color to a different value. Now let's slide down to search for our reset highlight glow. So let me paste the code here. And we are going to simply check if we are not glowing, then we are going to return because there is no point in resetting anything. If we want to reset our glow, we are going to look for each renderer in our glow material dictionary.keys. So again, we are going to get the reference to our renderer for each var item. So this will be our material, so material item in glow materials dictionary renderer. So for each material we are going to get the item set color glow color to the original color. So this way we are going to reset our glow color to be the original white. And I don't think that we even need to set the materials to our glow material dictionary.render, because we are basically modifying the same materials to be in the original color. Now we can copy this code, although we could of course encapsulate it in some method and basically find the second method that we have created. Here it is, highlight valid path. And I'm going to paste the code, and instead of setting the glow to the original glow color, I'm going to set it to the valid face color that I have created above. This will be the color green. So basically, this will be it for changing the color of our hex. Great, let's right click in the hierarchy, create a movement system. And we are going to add to it our script movement system. Okay. Now we are going to need one more script that will be responsible for selecting the unit or the hex and translating this message and sending this message either to the unit or to the movement system. But for now, let's open our selection manager and let's implement it in a way that we can simply assign to it a functionality of some sort. So I'm going to create below the list of neighbors a Unity event, and actually we do not need to have this list of neighbors or the Hex Grid reference. And this will be public Unity event game object, unit selected and terrain selected. Now to use those, right click here, quick actions, and say using Unity engine.events. Okay, great. So now instead of handling this by calling the hex and all of those, let's delete this code. We're going to have a simple if statement, if unit selected method that will take in the result of our find target, and if this is a unit, we are going to call unit selected (invoke passing this game object, else we are going to invoke terrain selected (invoke), and we are going to pass the result, so the game object. Now unit selected, right click, quick action, generate this. All we are going to do here is we are going to return a bool value. We're going to check if result.getComponent contains the unit component. If this is null, then we are going to return false, else we are going to return true. And I think that we have conflict between the names, so let's type on unit selected for the Unity event, and I'm going to change this here. So now basically what we are going to do is click on a unit or on a hex. If we have clicked, depending on the layer mask, on a hex, then we are going to invoke this event, terrain selected, else we are going to invoke on unit selected, and now selection manager doesn't have to worry about what happens with the unit. And let's prepare our selection system. So now what I want to do is set the selection mask to be also the character, and as you might recall, our unit prefab is on the layer default. So now we are going to open the prefab and set it to be on the layer character, only this unit game object. Okay, let's save it. This video is getting pretty long, so I will split it in two, and in the next one we are going to finish this system. See you there!